Yeah.
You are modeling systems with interactions that broaden the opportunity and the appeal to orders of magnitude more people than not what was possible before.
Falling for deep learning, designing systems that detect and optimize human error. Skill-based human error can have catastrophic consequences. How do we implement adequate risk management efforts to aid human processes? Moderated by Stephen Meade, MonetaPro, Alexiei Dingli, University of Malta, David Orban, Network Society Ventures, Miro Svetlik, Aire.one.
Good morning, everybody. Looks like we don't have Toufi. That's okay. We'll move along. So, little background on me. I've done a ton of work in technology, but I actually didn't know a lot about this particular subject, and I love that because it allowed me to study. So we're going to go through traditional, typical, we're going to make introductions, but have a little bit of different stuff. We're going to start with Alexiei here. Fun fact. I like fun facts a little bit about him. Won a lot of awards, won a Malta Innovation Award, and was the former mayor of Valletta.
Not sure if it's fun or tragic.
Fun or tragic, we're not sure. So give us a quick little introduction and we'll move through and get into the topics.
Okay, so hi, I'm Alexiei Dingli. I'm a professor of artificial intelligence at the University of Malta. I've been working in artificial intelligence for the past 20 years, much before it became fancy. As you said, I was the mayor of Valletta for the past 10 years as well. I stopped last January. I was involved, and still am involved in different AI projects, both locally and abroad. And last year, I was also on the Malta.ai national strategy, which was launched last month. Thank you.
Perfect. And then I have a quiz for everybody. This is how we're going to wake each other up. Again, I didn't know this. We had a little bit of a tip here. How many of you think AI, artificial intelligence, has been around at least 10 years? Raise your hand. This is an easy one. There's no trick answer. 20 years? 30? 40? Yeah, that'll lead us to David. I had no idea artificial intelligence has actually been around 30 plus years. Pretty amazing. So David, give us a quick little introduction. You're sort of the legend on the panel here for how long you've been involved.
When I started, a lot of things that we wanted to do couldn't be done, and many in the field believed that they could never be done because computers would never have the humongous memory of 1 megabyte that would be needed in order to implement the kind of software that was at the time envisioned. So now, a few years later, we know that 1 megabyte is achievable, and the things that at the time we could only dream of are literally part of your daily lives in terms of what AI delivers.
Actually, if I can add to David, there's the famous quote of Bill Gates, no? Which I believe he said, "Why do you need more than 48K?" You know.
Well, I will take any amount of memory you will give me and max it out. I guarantee you the things I want to do need much more than we can have.
Yeah, I've learned that computer memory is like ether. The programs just fill whatever space is there, and you always need a bigger room. And what David's talking about is interesting because there's a singularity moment coming, and you'll learn in a moment why I said that. And there's also some interesting things around sustainable robots, and Mino's got a great little background of some things he's done, so.
Well, that's maybe the fun fact about me, that I invented the portable sustainable robot, and I believe that because industrial robotic revolution is already nearly on its plateau, there is coming the consumer robotic revolution, and we will see the robots which are around in our households, acting upon our acts, and which are sustainable, which do not consume a vast amount of energy like industrial robots.
Yeah, very cool. So if any of you in here are considered experts, I apologize for this next question. I was fascinated, and I questioned some friends of mine that are experts, and I learned a difference. And I want to hear each of your opinions on this and distinctions. There apparently is a difference between big data and how you analyze things, artificial intelligence or AI, machine learning, and then deep learning, which is even different and deeper than machine learning. So as best you can in a non-academic manner,
I'll try.
Give us your opinion, Alexiei, of the difference of those four categories.
Okay, so latching to what you said before, AI has been around for 70 years. Okay, so even though the concepts were there before, but technically after the Second World War, people started working on AI. And in fact, the term was actually coined in 1956. So AI started growing. At the time, they thought, listen, let's do a 2-month workshop and we'll solve AI. And practically, we haven't solved it till now, so we're still working on it. But what happened is then AI got divided into different subfields. And you find fields like computer vision, where the AI looks and interprets what he's seeing. Natural language processing, where the computer speaks and understands what you're saying, and different other fields. Now, one of these subfields is precisely machine learning. And machine learning is a subfield of AI which deals with the actual learning. So when a machine learns something. Now, at this stage in time, at this point in time, machine learning is, let's say, the superstar subfield of AI, because a lot of machine learning is being used in all the other subfields which there are. And machine learning is also made up of different algorithms. And one breed of algorithms, the most famous at the moment, is precisely deep learning. Okay, so to recap, there's AI, machine learning, and then there's deep learning. All right, why is deep learning so important? First of all, deep learning is based on technologies which were invented really and truly back in the 60s. All right, neural networks. So they're based upon how our brain works. Now, what happened is that towards the 80s or early 90s, these technologies reached a plateau, and we couldn't improve them further. It was because of the technology, the algorithms, it was because of the hardware as well, because of the memory, so a number of different factors. But 10 years ago, we managed to go beyond what was the plateau in the 80s. And this happened because there were new algorithms, more processing power, like the cloud, for example, and the GPU, which is very important, and of course, a lot of data. And the combination of these allowed us to create the achievements we have today in deep learning. And that leads us to big data. Big data is more of an application of AI, whereby there's so much data that it's impossible for humans to process that data. And because of that, we use AI to process it.
And Miro, I see you shaking your head, so let's not go much deeper. Do you agree with most of those points? Because I think David may have a little different take on it.
Well, I agree from the technical perspective that the GPU and the cloud processing power enabled this, but obviously the complete understanding, we do not have the complete understanding of all algorithms and how they are proceeding, because some of them are working actually as the black box. And then what you see in the industry, you are seeing actually the empirical use of these networks. So we are more fine-tuning them based on the results than actually understanding what they do.
Okay.
Yeah, I agree.
When you are tagging your friends in photos on Facebook, you are using AI, you are training AI, you are actually coding AI.
Yeah.
And the huge difference between an approach that could have been applied 20 years ago and today is that in order to be at a certain level of abstraction, an AI developer that produces useful code, you are not using a keyboard anymore.
Yeah.
You are modeling systems with interactions that broaden the opportunity and the appeal to orders of magnitude more people than not what was possible before. And this is an incredibly powerful approach that we need in order to rapidly understand what is possible, because a few people won't be enough to do that.
Yeah, and I think that gives us a good segue, because the topic is, what are the consequences of human error versus artificial intelligence versus a human process? What you gave us, David, was a very simple one. Every time we tag a photo, we're helping the algorithm learn facial recognition. And that facial recognition, if we're studying, it can be used for good or bad. You've got social scoring in China, which has some interesting applications that are potentially very destructive. You've got facial recognition and other things. Yeah. let's talk about, because I know you've been with Singularity University for a while, which is the singularity between human and interface. That's why I thought the robotics side was interesting.
Yeah, may I step in here? Because actually the term singularity has been coined by Ray Kurzweil.
By Ray.
And actually it means when the computers will supersede the human brain. Yeah.
Correct.
So he said that this event will happen in 2045. Yeah. And I wonder if it's going to happen, because
the manifestation out of that is Singularity University. If you guys aren't familiar, Reese and some other guys, David's actually part of Singularity University and that founding of that point where things merge.
I was part of the team that designed Singularity University at NASA Research Park with funding from Google 10 years ago, based on the original article that Vernor Vinci, the science fiction author, published with NASA in 1993. The technological singularity is this hypothetical point in the future when AI crosses, for a very brief moment in time, the level of human intelligence. Because forever afterwards, it will just be more powerful, never less. So, is this possible? Those that are not of a metaphysical opinion of the source of our self-consciousness believe that it is possible. It has been possible already once in us. There is no reason not to make it possible more than once. And of course, it is a momentous event that if we can, we must plan for. Biological evolution doesn't care about killing thousands of species and billions of individuals in order to find solutions. We don't want to be those that are killed in the process of finding better solutions in the future. That is why we have to plan what is happening with very, very open eyes and alert awareness.
I think.
I was gonna move to you, Alexiei, because what David was talking about with NASA and things. I know you've done some area with NASA and space as well.
I just wanted to add a parenthesis to what David was saying. I agree totally with what he said, but we have to explain the current level of AI, because we tend to hear a lot. Listen, AI is the master in chess. Now AI is the master in Go. Recently, AI became the master in StarCraft, which is a game. So people start thinking, so at which level is AI? Now, AI is generally divided into two. There's the narrow AI and the artificial general intelligence. Now, the narrow AI is the AI which is doing all of these advancements. And in particular, it's called narrow AI because it's very good at doing a particular task. So playing chess, for example. But if you ask that AI to do something else, I don't know, tell me the weather of tomorrow, predict the weather, AI is not capable of doing that. Why? Because it's very specific AI. So when it comes to narrow AI, then AI is excelling and it's going beyond what a human is capable of doing. But when it comes to AGI, to artificial general intelligence, that sort of AI, which is capable of handling a lot of things, then I think we're still a little bit far back over there.
Yeah, exactly. And if I can jump in, there is actually the pledge of the companies which are developing the AI and the robots to not use them to the military and the evil purposes. So there are already people and like engineers and scientists which are thinking about these possibilities, and they are actively working on that.
Yeah, so let's go down the thread of the topic here for a moment, because it's talking about human error, catastrophic consequences, how does AI aid it? And when I looked at that and I looked at the background, one of the most prescient opportunities, I think, is around space and space travel. How do you use artificial intelligence in making better decisions in something along the lines of space, exploration, and then we'll actually end with food in some of your background in CPG. So let's start with the food side, and then we'll end with the bigger things in space.
Exactly. Okay. So basically, my startup Aire.one, which is busy in the consumer packaged good and retail, is more looking actually at the prediction of the trends. Trends in the market, trends in the advertising. It can actually help you to minimize your return on. It can help you to maximize return on investment on your advertisement. And it is happening because we can analyze the data which customer has. We can connect other data to it and run it through the recurrent network. And that gives us the higher level knowledge. So we can identify specific factors, specific drivers which are guiding it. And we can also identify anomalies, and that's maybe interesting also in the financial world, where you can see in the amount of data which cannot be processed by human daily, the problematic or anomalous events, and then act upon them.
Okay,
Yeah.
good. And then David, I know the work at Singularity, if you're still involved, they're always trying to solve big, complex problems. Pick one example where you think artificial intelligence will help decision-making of something that could have big consequences.
Can you raise your hand if you heard of the trolley problem? Okay, the trolley problem is when academics enter a state of mental masturbation and stop understanding the real value that rapid deployment of concrete solutions can bring. It is especially frequently brought up in the case of self-driving cars, where the hypothetical question is, oh my God, what is going to happen if the car must choose in a particular situation between person A and person B, and one of them will die? Shouldn't we be more careful rolling out self-driving cars, because if the car cannot decide or it makes the wrong decision, then the wrong person will die? Now, the reason why this is preposterous is because there is no right person to die. So it's not that the wrong person will die and then the right person will die. Yeah. But the even more important issue is that it is expected that self-driving cars will reduce human mortality due to car accidents by 99.999% anyway. So don't worry about the hypothetical crazy event that may happen once in a million if in the meantime you'd save 1 million lives. And this is an egregious example of how our systems include human error, which we totally accept. Any country, and I don't know the statistics for Malta, but for example, in the United States, about 30,000 people die per year in car accidents. So the United States today is saying our transportation infrastructure benefits outweigh the cost of 30,000 people dying per year. We are fine with that result. Well, I am not. And the Indian Ministry of Transportation, for example, said a few years ago that he will never allow self-driving cars in India because the tuk-tuk drivers would lose their jobs. Now, I am absolutely sympathetic to those tuk-tuk drivers who will lose their jobs, but the Indian Minister of Transportation, he said that he would prefer 100,000 Indians to keep dying every year.
Yeah, and sometimes it's a moral decision backed by a data decision, and those aren't the easiest. I actually don't believe self-driving cars will ever get here en masse because I'm waiting for this autonomous taxi that will get me through the 405 in LA in 8 minutes, not sitting in an autonomous car for 80. So I'm waiting for my autonomous taxi. But wrapping up, Alexiei, give us a good example use case of where you see AI or deep learning where it could further the human cause.
Yes, I can give you an example we're currently working on, something called digital twins. So we're working with a large manufacturing, but this example can be used for anything. Last week I gave a talk on aviation, and you can very easily do it in aviation. So the idea of a digital twin is that you create a virtual replica of the physical object. It will get live data, real-time data directly from that object, and you can access that virtual replica practically anywhere. So from here, I can know how the aeroplane is doing in the sky, the real one. Now, the power of that is twofold. First of all, there can be numerous predictions. So I can predict when there will be a fault on that aeroplane before it actually happens. What sort of maintenance is required? The second one is that I can also test the future. So I can actually make changes on that aeroplane, virtually see how it will go, and then, of course, apply it on the real object. But I think this will give us an incredible amount of power, and at the basis, it's all about AI and deep learning.
Yeah, perfect. And then just wrapping up, Toufi wasn't able to make it. Any of you that know Toufi, he's got Toda networks. Miguel and his team is around here somewhere. The future of now Media Group. There's a great documentary about Malta and Iman and the amazing work that AIBC is doing, and Toufi's actually got a really cool interview in there. So any of you guys that want to find that and learn more about him and Malta and the work around AI and what AIBC is doing, it's The Future of Now is the documentary. Other than that, big hand to the panel. I've learned a lot. I hope you guys have as well for as early as in the morning. Thank you.
Thank you.